Hi guys, welcome to Statistics Online. Today we are looking at lesson 1-7. So you're going to be very good by the end of this lesson to be able to do two things: to calculate and interpret standard deviation and to calculate and interpret the interquartile range. Okay, so let's get started. I'd like you to give yourself a nice title in these notes, 1-7, Measuring Variability. So here are some important ideas. The first thing is when you're given a set of data, and let's say you want to find the range, we would want to do the maximum value minus the minimum value. For the IQR, the interquartile range, it is the third quartile, subtract the first quartile. And the standard deviation is the typical distance away from the mean. And so the Q1 is the median of the first half. The Q3 is the median of the second half. And so let's say that for your particular set of data, you are looking at the median. If you are looking at the median, then you should also be calculating the IQR. If you are looking at the mean of a set of data, then you should look at the standard deviation. Now, the greater the standard deviation, that means that the greater the variability. That was a lot in a small amount. Okay, so let's apply it. So let's think about all of the colleges that you plan to apply for. And let's use a small data set. I know in this it says a group of 4, which we can't do really groups at all, but let's go ahead and just list off a very small amount of data, so that way calculating standard deviation by hand isn't so bad. So let's go ahead and say 3, 3, 4, 5, 5, 6, 6, and maybe a student wants to apply to 8 different colleges. Okay, so let's say that you'd like to look at the median of this data. Okay, so I'm going to switch to the next slide. The next slide has like a whole bunch of information on how for you to do this by yourself. So listing and finding the quartiles. So you're going to list the data below from least to greatest. Very important. And we kind of already did that on the last slide, so I'm just going to do it again. 3, 3, 4, 5, 5, 6, 6, and 8. Okay, so now we're going to find the median of our data. So the median of this data is directly the middle. We have 4 and 4 on either side. And so therefore we're going to take those two 5s, add them together, get 10, divide by 2, and the median is 5. So median is 5. Now that has taken our data and broke it up into like an upper and a lower, basically. So then next, to find the first quartile, we're going to find the middle, right, the median of our first half here. So to do that, we're going to look at our data set, and so the median would be in between 3 and 4. So this median is going to be our first quartile, and that is going to be 3.5. Likewise, let's do it to the other set of data. The 6 and the 6 is the middle. When we add the two 6s and divide by 2, Q3 is going to give us 6. All right, awesome. So now that we've done that, now let's go ahead and look at the range. The range is going to be the greater number of our set of data, which is 8, and subtracted by the smallest, and that is 3, so our range is 5. And then our IQR, our interquartile range, is Q3, which is 6, minus the Q1, which is 3.5, so our IQR is 2.5. Whew. All right, hopefully I didn't go too fast. If I did, you can replay it over. Try and keep it short for you guys. Okay, so now let's find the standard deviation. Let's take that same set of data, and now let's say that we want to look at the mean. And when we do so, we want to also look at the standard deviation. I'm going to rewrite this data because I don't have it here. So it was 3, 3, 4, 5, 5, 6, 6, and 8. Okay, so this beautiful, beautiful piece of math is how we can't calculate the standard deviation, right? This is summation x sub I minus our x bar squared all over n minus 1, and this fraction is all under the radical square root sign here. Okay, so the first thing that we're going to do is we're going to find the mean of our data. So step number 1 is to find x bar. So the mean of our data is adding the 3, 3, 4, 5, 5, 6, 6, 8, and then dividing it by how many there are. So I have 40 divided by 8, so that means our mean is 5. Good. Next, we need to find the distance away, right, from each set from the mean. So this is how I like to set it up. We have 8 of them, right? 1, 2, 3, 4, 5, 6, 7, and I'm running out of room, 8. Okay, hopefully that all fit in there. So then we are going to, and we're looking at this here, we're going to take all of our values, the 3, the 3, the 4, the 5, the 5, the 6, the 6, and the 8. And we're going to subtract the mean, which we just found, which is minus 5. Subtract 5. Then we square. Make it positive. We're going to do each of those individually and add them all up, which is what the summation here is telling us to do. We're going to do this each individually and add them all up. So now let's go ahead and write that down. So this first one would be 4, 4, 1. This one's going to give us 0, 0. This one's going to give us 1, 1, and 9. Now, when we add all of those data points up, right, 4, 4, 1, 0, 0, 1, 1, 9, looks like we get 20. So now we have the square root of 20, right? That's what happened. All of what we just did was this here. And it's over n minus 1, and n is the number of data points we have in this set. And so we have 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, 8 here. Good. So it is over 8. But it's n minus 1. Oopsie. Let's go back. There we go. So it's n minus 1, so it's 8 minus 1, so that would be 7. So we have the square root of 20 over 7, and that is going to give us true. Let's calculator, square root, 20 by 7. That is about 1.69 standard deviation. Right? So from the mean of 5, our standard deviation is about 1.69, which means in both directions, right, our data is between, most of it, right, the mean is in between 1.69, either swing from 5. Right? So let's take a look at that. So if our mean of our data is 5, then our standard deviation is going to be 1.69 in either direction from that. Okay, that's it. I hope you guys are having a great day, and I'll see you next time. All right, thanks. Bye.